Okay, perfect. Good morning. So we're going to pick up from where we left off last week on lesson 4. So I would like to just go through, like, summarize what we did last week when we introduced lesson 4. So we talked about Boolean statements. What are Boolean statements and how to write Boolean expression. We also discussed the different operators in Boolean expression. And if you remember, we talked about the logical operators, we talked about relational or comparison. Some people also call it the um, entity operator. So we talked about those things. And if you remember, we talked about relational operators as the greater than equals to, less than or equals to, not equals to, we talked about the double, the double equals operator. And we really talked about the difference between the assignment operator, which is the equal symbol, and the double equal, which is more of a relational operator. The double equal is always saying this is equivalent to this. However, the assignment operator is initializing, at that point where we're initializing a value to a variable. So the assignment operator is really helping us to store data in memory. It assists the compiler. It instructs, that's the instruction we're giving the compiler. Hey, compiler, put this value in the container of this variable. However, the double equal here is saying, oh, compiler, can you check? Is this two variable or two value? Is it equivalent to each other? So that these are two different functions. They're useful, two different purpose in programming. And it's very, very important we understand this difference, especially uh, especially going forward in this class. So we also talked about the short circuit evaluation, and we discussed the different ways we use this short circuit evaluation. Just a quick question. Um, why can't we use the exclusive all? Why can't we use the exclusive all in short circuit evaluation? Can anybody remind us? Please use your charts, unmute yourself. We talked about short circuit evaluation last week, Thursday, and we said exclusive all operator does not work with this evaluation. Why? Can anybody remind us? Unmute yourself. Use the charts. You can also turn on your video. Let me see. Turn on your video. I want this class to be interesting, to be interactive. And we are building on foundation. We're taking this class. You don't need a proud programming knowledge. So we're building up, on the things from lesson 1 to lesson 2. Can anybody remind us why exclusive OR cannot be used for short circuit evaluation? Anybody willing to go? Short circuit evaluation. We discussed that last week. And we said um, it helps the compiler, the computer, to shorten the time it takes to execute Boolean operation. And I remember last week we said this evaluation can work for and not equals, However, it cannot work for exclusive all because from the definition, if you remember in the last class, from the definition of exclusive all, it says exactly one of the operands here must be true. So the computer needs to check the both. The computer needs to check the both condition. The computer cannot just stop on one condition. You know? So it tells the compiler, the exclusive or tells the compiler, you need to check the both. So if the condition one is not true, then you have to go to condition two to check. However, um in plant, for instance, the double ampersand operator, it said at least all, this is not at least, the all is the at least. But here it said all the conditions must be met before the and operator can be executed. So it means the condition one must be true, the condition two must be satisfied. And if we have more than two conditions, so all the condition must be satisfied. So in the sense, if the first condition is false, so it tells the compiler, I don't need to check the second one because in the AND operator, all the condition must be satisfied. So the compiler just stops there, right there. So it saves the time. Saves the time instead of having to go through, when you have maybe 10 conditions, for instance, instead of having to check the entire 10 condition, the compiler stops at the first one, which is first, which is not met. And it's similar for all. So for all operator, at least one of the conditions must be met. So for instance, we have two conditions, or three, or four, and the first condition is true, all right, at the first condition is true, then the compiler will be like, oh, you don't have to go through the other conditions because at least one must be true. So if first one is true, then let me save the time for other things. Let me save the time for other things. So I don't have to go through the other conditions because the first one is met. The first one is true. And that's what the or statement is saying. At least one must be true. And the first one is true. So do you understand the difference between the logical operators? Thumbs up if you understand the summarization, the revision we have made. And thank you very much. And that's why the exclusive or, the exclusive or cannot work with short circuit evaluation. Why? Because exactly one has to be met. So if the compiler is on the first one and it's not met, the compiler goes to the second one and it's not met. The compiler goes to all the conditions. The compiler must execute all the conditions. All because maybe the last one will be true. So the compiler doesn't just stop at the first one because exactly one must be true. So that's the difference between the logical operator, and it's very, very important we understand this difference because going forward, we do not have, some kind of sequential code that we've been writing so far from lesson one. Going forward from lesson four, we will have some conditions, we'll have some condition. We'll be telling our compiler, we'll be giving some instruction that you have to do this in this condition. You should do this in the other condition. So you need to understand the difference between these logical operators. Extremely important. So any questions or concerns before we introduce today's concept? If no questions and concerns, please wait, we're going to learn a statement today? Sure, yes. We are learning if statement today. Because now we understand, yeah, now we understand how the logical operators work, how the relational operators work. Then let's see how we can use them to build conditional statements. And that's what we'll be discussing today. So, if no questions and concerns, if no questions and concern, can you thumbs up for me so we can? Okay, so if you go to your model page, you'll have this notes, and it's I think the second slide, the second presentation here on your lecture notes. So, and we will be discussing the conditional statement. Okay. So what is the objective? Why do we have to learn this? Why is it important? Because we said we want to start building, we want to start building expression. We want to give instructions to our compiler to behave differently in different conditions. So these are the objectives, these are the things we want to learn. We want to understand how nested control flow works. We also want to, I want to give you the basic, which you guys have to read your textbooks. You have to do your Zybox assignment to also learn more on the difference between the if statement, the if else statement, the difference in the switch statement and the structure, the syntax. How do we write them using the Java programming language? So, this is a very self-explanatory slide, or I will say diagram. And what do you understand from this diagram? What do you understand? Anybody just looking at this diagram? What do you understand? You can use the charts. You can use the charts. You can unmute yourself. Just looking at this diagram, what do you think? Unmute yourself, use the chats, turn on your video. I'll be much happy. I'll be glad to see you on camera. It's a crossroad of choices. Great, thank you. Thank you very much. And that's absolutely correct. If you see the first diagram, and this is like what we've been doing, it's straight down, it's straight road down. And this is an example of the type of programming we've been writing so far in this course, and we call it some kind of linear, some linear sequential programs. So if you observed or if you notice the kind of code we've been writing from lesson one until this moment, you see we're following, the code runs one after the other. All lines of code have been executed. All the lines of codes that we've written are being executed one after the other. So it's kind of a sequential, a linear kind of programming writing approach or code writing approach. But now we are introducing some choices. We are introducing some conditions. And here you see at this point, the compiler needs to make a decision. Am I to go right or am I to go left? And that's what the branching statement is all about. Here, not all the lines of code are being executed because at this point, the compiler makes a decision. I am going to execute the right because the left is false. It could be more than one, it could be more than two branches. It could be multiple branches, talking about 5, 10 branches. And the compiler has to make a decision. Which routes, which road am I to take? So this is the clear difference from what we have been doing from the beginning of this class. We have been using the first diagram, having our line of code runs one after the other in a sequential manner. And now we're introducing some choices for the compiler. We're introducing some branches for the compiler. We're telling the compiler, we're telling our computer to make decision here. Thumbs up if you understand this. And this is the basis when it comes to branching statements, branching programming. Okay, so let's, what is conditional statement itself? This is a statement that helps, that let us to choose. It tells the compiler, make a decision. Choose between A, B, C. And in this kind of statement, not all line of code is being executed from the example. So if A is true, then B is not executed. And that's the purpose why we need our logical operators, we need our relational operators in building up this branching statements. So they're sometimes called selection statement as well. We're selecting, you're picking one, you're picking two, you're selecting the line of code. You're telling the compiler, make a decision and select the line of code that satisfies this condition, that meets this condition. So you're given power to make basic decision in conditional statement. And we have the if statement. If this is correct, do this. And we have the if statement. If this is correct, do this, else do this. No, those are the kind of instruction. I want you guys to please take notes. Take notes, interrupt me, questions. No, unmute yourself and ask questions. Use the chat. It is very, very important we understand this concept. I can't emphasize this enough. So the if statement is telling the computer what? Hey, if this condition is met, do this. The if else is saying, hey, if this condition is met, do this, else do this. And we have a switch statement that is multiple, that's multiple. You're given multiple if statements. The if statement is always a standalone, for instance. So you say, okay, if it's not met, then it's fine. The if else is a two-way. There's a two-way statement. Call it a two-way statement. And that is telling the compiler, if this is not met, then okay, else. Let's see if this is met. And the switch statements, we call it the multiple, the multiple switch, the multiple if statement. So you have more than two if statement. Any question? So it's just what I've explained now in the slide. The if statement is a single selection, so it's standalone. You're telling to select or ignore a single action or group of action. If this is done, okay, do it. If not, and that's where we have it. And the else statement is double. So it's a two-way thing. And you're telling the compiler to select between two different actions. And the switch statement is the multiple selection statement because you have more than two actions. You're telling the compiler. Oh, first is not done, the second should be done. If the second is not done, then let's say do the third one or do the fourth one. So, any questions on the difference between the three conditional statements, the three conditional statements, if statement, the if else statement, and the switch statement? Thumbs up if there's no question. Yeah. I'm really, really taking my time, and I'm trying to make it as self-explanatory as easy as possible, because we have people from different major in this class. That's one. Also, because this is a foundational class where we don't need a prior programming experience to take this course. However, it is very, very important you take note of these concepts, and learn the syntax, know how to use them. The structure is the structure is the same across the different programming language. However, the syntax may be different from one programming language to the other. But I tell you, if you can write this very well using Java, then you can do well using Python, C++, C Sharp. So it is very, very important. If you have any question, if you're confused about something, if you need further clarification, interrupt me, ask questions, send me Canvas questions, inbox on my inbox on Canvas. Um, come to the virtual office hour if you have any question whatsoever. So just what is the syntax? What is the syntax? What is the syntax of the if statement? This is the standalone statement. And it's so easy. Let's come to this flow chart diagram. And you see, if this is a reserved keyword in Java, this is a reserved keyword, and this is the computer understand it. Now, once I see if, the programmer is trying to tell me to make decisions here, to make choices here. And what follows? What do you think? What follows the if statement immediately? What follows the if statement immediately? What do you think? Immediately after the if statement, we must have the Boolean expression. We must have the Boolean expression. What condition do you want me to check? And that's immediately after the if statement, we have the if, you must have the Boolean expression. Then this expression is true. If this condition we have written here is true, then do this, operate, execute statement one. If it's false, then execute statement two. And a question. Okay. So let's say, so we're starting with if, which is a reserved word. You cannot use reserved word. You cannot name your variable using reserved word, because these have specific meaning to the compiler. They have specific. The compiler understand this as something else. So if you use if to name your variable, you will be getting an error. So they are reserved words. And what is the expression? What is the condition? And this condition has to be in parentheses. 5 is greater than 4. So if 5 is greater than 4, what happens? what should I do? That's what the compiler will be looking for. Okay, okay. So if 5 is, what should I do? And if you say here we have a color brace, why do you think we have a color brace? Because conditional statements also mark the start of a new code block. So in addition to giving your code some structure, you're giving it structure for clarity's sake, for visibility, in terms of its functionality, it also helps for readability of you, the programmer, and even anybody that will pick up your code. So you open the calibrates immediately after the condition. Within this calibrates, you have your what? Your statements. However, I need to also emphasize this. Your statement is just one line of code. If maybe once this condition is met, you just want the compiler to do something in just one line of code. You may ignore the curly brace. The curly brace could be omitted or can be omitted. The curly brace can be omitted. If you have just one line of code, one line of actions. However, if you have more than one line of actions, more than one line of action, then the curly brace is important because it tells the compiler, hey, if this condition is met, then I want you to do the following blocks of code in the if statements. But if it's just a single line, the compiler automatically understand, oh, I think the programmer wants me to just do this if this condition is met. However, if you have multiple lines of actions without this calibrate, even you, will it helps you to read your program? No, it may be confusing. So it is very, very important. The calibrate is very, very important when you have more than one. So if you have multiple, for instance, multiple actions that you want, and it takes this actions is taking more than one line of code, then please ensure you use the calibrate. It's very, very important. It's the standard. And also indentation. Indentation is actually not for the compiler, to be honest. It's actually for us, the readers, the users. I want to come back to this program and be able to understand. I don't want everything on the same line. This will be so confusing. I want to know when the specific condition statement is starting and when this condition statement is ending. So it's for readability of the user because, of course, the compiler ignores all this in the others space, line spacing. I think we did that in the first class. In the lesson, yeah, the first lesson. So it is very, very important when you have more than one line of code, more than one line of code, more than one actions, you should use your calibers, the open and close calibers. Very important. However, the last statement, the last command here, this action is not associated with the if statement. That is why it is outside. So if this condition is not met, if this condition is false, then it's, this is not part of the if statement because we are not writing if else. We are not telling the compiler to do another thing. So this should be out of the calibers. So if 5 is not greater than 4, or if 5 is, I said not, I'm sorry. If 5 is greater than 4, there is no not here. If 5 is greater than 4, do this. So in this kind of code, what do you think will happen? Please, what do you think? Is 5 greater than 4? Yes or no? Anybody? It's so boring. Thumbs up if you understand what I just explained because it's so boring. I'm asking if 5 greater than 4 and nobody's responding. I think I'm speaking to myself. Okay, yes. I think I'm speaking to myself. No response. So bad. So if you understand how the if statement syntax works, the importance of the callibers, why you need your if, why the if statement should not be used to name a specific variable. I'm only saying Kayla and Shans, I need other people to thumbs up. If you have any questions, please interrupt me. Happy, thank you. I need more thumbs up for me to be satisfied that at least. Thank you very much, Madis. So this is how the if statement, the syntax of how the if statement works. So this is just a short, still the same thing, still a short description. So we said int grade. This is we're declaring a variable grade. And in the second line of the code, we are initializing grade to 80. So is 80 greater or equals to 60? Yes. Because 80 is greater than 60, what happens? The compiler comes to this and say, okay, oh, yes. So the compiler does what? Prints passed. And also, if 80, if for instance 80 is less than is if the condition is 80 is less than 60, just from the flowchart, but here in the statement, 80 is actually greater than 60. So what do we have? Promised. So we've also discussed about indentation. It is very important because it helps, it helps us to easily read and understand uh, the code. It helps us to understand, to read the code or the program itself. So, like I said, it's of no use to the compiler because the compiler ignores. But of course, it is very, very important because it enhances the readability of our code. So let's have a quick illustration of the if statements. And if we go to the model page, do we have our IDEs open? Thumbs up if we have our IDEs open. So if we go to the code, thank you. So if we go to the model page, um, we have the code inspection folder, like I explained in the last class. And in the code inspection folder, we have the simple if demo. The simple if demo. So I want you to download it, click on it, copy this code, copy it, and paste it on whichever IDEs you are using. Uh, we will be using that. Okay. Can you see my screen? Is my IDE visible? Okay, perfect. Thank you. So copy, paste, and let's just run through it. All I did was just to copy and paste as well. And I just add few comments because I like my code to be self-explanatory to whoever picks up my code to read. So the first line, why are we importing? Why? Why are we importing? Because we will be requesting the user to provide us some value. So we need to import this scanner class. We need to import this scanner class because we will be requesting the user to provide some values in this code. Of course, we are opening our class, which is the name is simple if demo, and we open the main method, very important. And because we are requesting value from user generated value. We want our users to provide us some inputs. So name the scanner inputs. This is the object we just created that will hold this value. And we already, I can overemphasize this, that this is telling the compiler this value will be provided using the keyboard system.in. In the next line, we are prompting the user to provide an integer, enter an integer. And here we are declaring and initializing this variable called number to the user's value, to whatever value the user provides from the keyboard. And this is where we have a Boolean statement here. So um, we're telling the compiler, if once the compiler says if, the compiler, oh, then what should follow? It should be a Boolean expression, a condition. Okay, if number, which whatever value the user inputs, is divisible by 5 and the remainder is equal 0, 0. So the double equals here is what? Equating. So we are the equivalence of this calculation must be 0. Then why don't we have the curly braces? Can anybody tell me why we do not have the curly braces here? To use functions. Thank you very much. Why don't we have the curly braces after these if statements? So the curly braces is left off because this condition statement has only one line of code. It's just one. These are two different if statements. So this specific if statement just have one line of action. If this is equivalent to this, if the solution here is equivalent to this, that's what I just told the compiler, print high five. And also, this is another if statement. So they are independent. These two if statements will execute individually because they're not the same. This is a different if statement, and we're given a different condition here. So we're telling the compiler, again, if whatever number the user input is also divisible by 2, and the remainder is equivalent to 0, then print high given. And let's run it and see. So I want to put 19. What happened? Can you explain what happened? Sorry. Yes. I'm having sore throat. Because 19 is not divisible by 5, and the answer is not equivalent to 0. 19 is not an even number. It's not divisible by 5, and also 19 is not divisible by 2 and equivalent to 0. But if I run it and I'm putting 20, for instance, what happens? Yeah, it prints the both statement because the both condition is met. 20 is divisible by 5, the remainder is 0 and is equivalent to 0. 20 is divisible by 2, the remainder is 0 and is equivalent to 0. Yeah, it doesn't mean the condition. Thank you very much. So, any question? Thumbs up if you understand how the if statement works, because we need to move to the if else statements. Thank you very much. So that being said, disconnect. So you have, like I said, you have all those codes. We will be using them in class for class activity. You can go ahead to run them to see how it's working before the class. Oh, it works. So let's go back to the slides, and that's exactly what we've done. So let's see what happens in the if else statement. So we said this is a two-way condition. It's always a two-way statement. So we're telling the compiler, if this condition is met, do this, else do this. And here we have what we call the if clause and the yeah, and the s clause. So because we're telling the compiler, if this condition is met, do this, else do this. Can you see the difference between the if and the else statements and the if else statements? Because here you see, um, here you see, when the condition is not met, what happens? When the condition is not met in the if statement, what happened? Nothing. So I'm putting 19, for instance. So nothing happened. This condition is not met. However, in the if else statement, so when the condition is false, the else statement is executed. And that's where we have the if clause and we have the what? The else clause. So one of this clause will be executed, not the two. So it's either the condition is met, the condition is true, and the if state, the first statement, which is the if statement, is executed. Or the condition is false, and the clause, which is the second statement, is executed. Do you understand the difference between the if and the if else statements? Thumbs up if you understand the statements. This difference. Thank you. So this is just, the syntax. What happened? What happened? We said if five is greater than 4, and we have what? The if clause, which is the action that should happen if this condition is true. If not, I think that's the opposite. So else, if not, this else clause, which is the action, should be executed. So it's just the same way syntax. Of course, we know the conditional keyword, which is our if. It's a reserved word in Java. We cannot use it for any other variable naming or for any other purpose besides this purpose. This is the only purpose the compiler understands this if statement to do. Immediately after the if statement, what should we have? We should have the condition, the Boolean expression. What should happen? So the condition here is 5 is what? Is greater than 4. We have to open the curly braces, like I said. Hey, do this. If this condition is false, then the compiler jumps to else immediately. So, oh, let me check. Then I have to print this because this condition is false. Don't forget the indentation is very important. It's for us to understand our code, for the purpose of readability. And in, I don't know, in our different compiler, we could use the tab, the tab key for indenting our statements. Also the curly braces, but it's also similar. It's also similar, the same thing we have in if. So if the condition, the action, the action that happens, the clause is just one of single line, we may omit the curly brace. We may omit the curly brace. However, if the action is more than one line, the curly brace is very, very important. Because if the action is just one line, compiler automatically understand, okay, I think I'm just to do this if the statement is true or if the statement is false. So I want us to take more. Yeah, exactly. So if the statement, just what I explained, you don't have to use the curly braces because the compiler automatically understand this. However, if you have more than one line of statement, it is very, very important we use the curly brace to tell the compiler this is a block of code, multiple lines relating to the if clause. This is another multiple line relating to the else clause. So, any questions, concerns, clarification, any? Let me know if I'm going too fast as well. Let me know if I'm going too fast. Makes sense. Thank you. So let's say this is just an example of how the if else statement works. And here we said int, this is an integer, and we're talking about the variable name grade. So we're declaring grade as an integer. So what does the data type tells the grade? Tells the computer, it tells the computer how to store grades in memory. The number of allocated memory that should be allocated to grade for an integer, 4 bytes. And grade is being initialized here as 50. And what happens? If the compiler, oh, what follows if? It's a condition. If grade, which is 50, is greater or equals to 60, do this. We may omit this curly brace because it's just one line. We may. What else? If grade is not greater than 60 or equals to 60, then do this. Is 50 greater or equals to 60? Yes or no? No. 50 is not greater or equals to 60. So the compiler jumps to the F statement and prints the F statement. However, you remember I told you this is a different statement. It is outside the if else statement. So of course, the compiler prints the statement as well. because this is outside. This is an individual statement on its own. Make sense? Are we good? And I want us to look at, I don't know, in our lesson two, we were talking about, yeah, I understand it. Thank you. In our lesson two, we're talking about Bob and Mary. Do you remember the specific example when we are talking about the life cycle of a programming language? And we are talking of a programming code, and we were talking about how do we calculate the weekly wages of two different sets of employees. We have some employees like Mary who work overtime, who works regular hours between 40 hours, less than or equals to 40 hours. And we have people like Bob who works over 40 hours. In this kind of problem solving, what do we need? We need a branching statement. This kind of statement helps us to differentiate, it tells the compiler, if you come across people like Mary, run this set of code. However, if you come across people like Bob, do this kind of. Hey, do we understand? And that's it. So we're telling the compiler, if the hours is less or equals to 40, which is the regular hour an employee to work. People like Mary just do the regular hour. Then calculate the pay, the weekly pay, as the rate multiplied by the hours this employee has worked. Else, else, if the pay is greater, so we are telling that else in the health statement, this condition is not met. It means the pay is greater than 40. I mean, the hours an employer's work is greater than 40. So people like Bob, what should happen? Then we need to include the increase in the hourly pay. So what should we do? And this increase in the hourly pay is for hours worked up to 40 hours. It's not hours within the 40 regular hours. It's outside the regular hours. And we say the rates multiplied by the 40 hours, which is the regular hour. What are we doing here? We are telling the compiler the hours this specific employer's work minus 40, because here we want to calculate the number of hours outside the regular. So this number of hours outside the regular should be multiplied by 1.5, because that's the instruction here. If you work more than 40 hours, you get a 1.5 increase in your pay, in your hour, in the hourly pay. So this here calculates the hours outside the regular hour, multiply by the increase. So if this employee is not like Mary, then do this for employees like Bob that is working more than 40 hours. Then that's it. Then we use the print statement to print what? The pay for any of the conditions that is met. Any question? Any question? Thumbs up if there's no question. Thank you. So let's go to another example. It is very, very important we understand this concept. going forward. So this is another example of an if else statement. And when you see this kind of declaration, we're talking about the car doors, the age of the driver, and the premium, the monthly pay. We are thinking, what kind of problem do you think we're solving here? What do you think is going on here? What kind of problem are we trying to solve here? Of course, insurance, your car insurance price, your car insurance price. And they have some conditions. Putting in some conditions here, like if the car doors, the kind of car you use is equivalent to four doors. So you're using four doors car. And don't forget the logical operator hand. The age of the driver is less than 24 years. So the driver is great, I'm sorry, is greater than 24 years. Is greater than 24 years. Then what should happen? What is the action? What action do you want the compiler to do if this condition is met? Then premium equals 250 $250 because giving them a low premium, yeah, because they are low risk drivers. They're greater than 24 years old. They have a four door. Do not forget, these both conditions must be met because it's an and. This is not all. This is not exclusive or. This is an and statement. It's saying this the car must be four doors and the age of the driver must be greater than 24 before you give the premium rates. What else? If any of these two is not met, any, this in and statement, the two, all the conditions must be met. So perhaps one of this condition is false. Maybe, however, the driver is above 24 years, but is using a two-door car, kind of car or kind of vehicle. Then the premium will be 1,200 because they're high risk. Or perhaps, in fact, the driver is using photo, but the age of the driver is 19, for instance, less, less than 24. What will happen? In and statement, the both condition, the two condition must be met. This is not an all operator. This is an and operator, which says all the condition. I mean, all the conditions must be met. So both the number of the car and the age of the driver must be met for you to have a premium price. If any of these two conditions is not met, then the user will have what? $1,200 because the computer perceived them as what? As high risk driver. So what happens? How much will the user be paying? And this is just, the calculation giving us premium divided by 12 months plus $5. But most important thing I want you to understand here is how the if statement works. How is it executed? What does the compiler do? In the exam, you have to think like a compiler. You have to act as a compiler. You're not writing code, but you need to interpret. You must understand. You must be able to interpret the statement or the code. Here, if it's an or, yes, either of the state, at least one of the statements. So either of the statement is true, and but this is an and statement. So the both conditions here must be true. Any question or concerns, please let me know if you don't understand. Thumbs up if you understand this. Thank you. Perfect. Yeah, we're good. Okay. So let's write this. I think our Heidi here is still open. And this is what we want to do here. This is what we want to do. This is what we want to do. So I need a hair. I said four. Because we will be writing this and it's very, very important. You follow along with me as we write. So what happens in this problem? We want to calculate the total bill. Of course, there are some conditions here. Discounted rates is 0.25 and the shipping cost is 10.00 if the purchase is over $100. However, the discount rate is 0.10 and the shipping cost is 5.00 if this condition, the purchase, is not met, is not over $100. So if it's the purchase is less than, then this should be done. And later we have to, just like the example we just discussed, we should calculate what the total bill is. But we need to know, is your purchase above $100 or below $100? So how are we going to do this? What do you think? How should we do this? How should we do this? What do you think? Unmute yourself, use the chat. We have to write, we have to solve this. Take the purchase integer with scanner first. Thank you very much. This is perfect. This is perfect. However, we're using double here because you can see there are two zeros after the decimal point. We need to make this program as interactive as possible. Thank you very much. We need to make this code as interactive as possible. So we need to get some information from the user. What is your purchase? How much did you buy this item? So what should we do? I hope you're following along with me and you're using my method. You can use any method that works for you, trust me. But what I do for organization purpose is to put codes written within each lesson in a specific folder, in the same folder kind of. So what do? I come here and I want to open a new class. And I have to call this class what? What will be the name of my class? What will be the name of my class? So I can just name it total bill because that's what I want to calculate. Please interrupt me if you don't understand anything as we write. So, like I said, I want this code to be as interactive as possible. So what do we need? What do you think we need to do here? We need to access this kind of class. And how do we access this kind of class? We need to import this class using the syntax. Please interrupt me if you have any question and we will in the statement. And once we have this kind of class imported, what should I do? I need to open my main method, or I can just write main, that's the beauty of having I do like to write it, but you can just write main and it pops up and you pick so what's the first thing? What's the first thing? What's the first thing we have to do here? Don't forget, don't forget our programming life cycle. And in our programming life cycle, what did we discuss? We said problem solving. We need to understand the problem we want to solve. It's very important to understand the problem. It's very important to specify the requirement in which is said one, which is which is you know yeah, which is we want to grab some variable from the user. That's one of the requirements. The purchase will be grabbed from the user. Also, the other requirement is to say, what are the variables needed? What variables do we need to declare? You know, you don't just jump into writing the code. First, we need to understand the problem at hand. Oh, we need a branching statement for this problem to solve this problem. And we need to get the value from the user. And we'll also need to know which variables do we need to declare to solve this problem. So let's declare um, the variables that were given to us from this exercise. So yeah, we declare variables. And the other thing you check, like I said now, is that you can see their decimal points, the decimal points. So, and when we're declaring decimal point, we declare them as, because they're floating points, as double. So the first is the discount rates, you know, and we say we can, once we have the same data type, we can always just declare them in one single line, separated by comma. Please check your other lesson. And we also need the purchase because we're grabbing that from the user, and the total bill itself, because we'll have calculating, that's what we hacks to calculate the total bill. And we had our terminator. So we have declared a variable we need to calculate the total bill. So what happened? What happens after declaring this variable is that we need to declare the object, our scanner object, which tells the compiler this variable or this value, we want a user generated value. We want to grab this value from the keyboard. And we have to create the scanner object. And that scanner, scanner object is mostly user defined. So you can always name it whatever works for you, whatever name. I just like to use the abbreviation. And the system that's in here is telling the compiler, I am grabbing this value from the keyboard. Do not forget. And what happens? We prompt the user. We had to prompt purchase value from user. Any questions so far? So once we have to initialize the value we get from the user to the variable we've declared purchase. So we're initializing purchase. And how do we do that? The variable we already declared equals, we're initializing it and equals to what? the object we have created. Done. What are we going to use here? Next word, this has to be next double because the variable we have declared is what? It's a double. Do you understand? If we have declared an integer, we will use next int because it's an int. But here it's a double. And here we have to start, we have to use the branch. The branching statements, you know, to determine the discounts rates and ship rate and ship cost based on purchase value. Any question? I'm just adding this comment so we can follow this code. So now what are we to do here? Thank you. So we said if. So what happened? What's the condition we want to check here? Purchase is what is greater. So if purchase is greater than 100, what should happen? And because we have, so we open our calibers. Any question till this point, until this point? Thumbs up if there's no question until this point and we understand this. Okay. Thank you. So we want to say if purchase is what? Is greater than 100. It's greater because it said if purchase is over, that's the instruction. We do not say if purchase is over equals to 100, is greater than 100. So the discount rate will be what? Will be equals to 0.25. That's the value we're given if purchase is over 100. Then the ship. So we said the shipping will be what? 10. $10 as well. We have to use the calibers here because we have more than one line of actions, more than one line of code within the if clause. So what happens if the purchase is less than 100? And that's why we need our what? Our else statement. Else. And we'll also open this calibers because we have more than one, more than one. So all I have to do is just to copy this, you know. I don't want to write too much. So I paste it. And I change the variable here because if it's less than 100, what should happen? The discount rate will be 10, will be 1.0, and the shipping is 5.00. Any question until this point? Any question? Okay. So what happens next? We want to calculate the total bill. Now we have given the condition. the compiler understand what's to do in the different condition. So let's calculate the total bill. And we already declared our total bill. So we say equals. We already have the formula here. So purchase. 1.0. So you already have that. You can always copy if you don't want to write. Everything will ship cost. And lastly, we should print. We want to print the total bill. So we want to call print, and we use the system.out or print line command because we want it to print on a new line. So the total bill concatenate here. You remember the concept of concatenating? We have declared. So let's run this and see what we have. So this is our end of main. Don't forget, I always like to add comments. And this is the end of class. Let's run it and see. So it tells me because we said we are getting this value from the user, and it asks the user to provide. So for instance, I'm buying, my total purchase is $30. So it calculates my total bill as 32. How can you verify or test if this branching statement is working properly? How can we do that? How can we do that? Well, all we have to do is to also tell the compiler. So here we want to verify. And how do we verify? We tell the compiler to print, let print the discounted rate. Print the discount rate. So we have to tell the compiler, print the discount rate and the ship rate you have used for this calculation. That's what we're telling the compiler here. So, I'm sorry. Discount rate. So we concatenate this with the value of discount rate. And we also enter ship cost. So we also concatenate. So let's rerun it and see what we have. I'm here to terminate my statement. Yeah. So I'm still putting my $30 as my purchase rate and say, any question? You can see it has given me the value, the discounted rate value, and the cost, the ship cost value the compiler has used to calculate my total bill here. Because the purchase rate is actually less than 100, is less than 100, so this condition is not met. The first if clause is not met, and the else clause was executed. Any question? I think we are right above time today. Any question? Thumbs up if there's no question. I will provide the code on Canvas. Any questions on if statements, if else statements? Thank you very much. So there is a short class reflection activity. Like I said, this is a way I take attendance in the class. So if you go to your assignments, sorry, you'll have the class reflection activity for today as 0217. Assignments, I'm going to leave student view. Because I want to get the okay, this is the access code. I'm going to paste it on charts. So that is the access code. It's just 4 point, yeah. I think it's 5 questions. I think it's just 5 questions. And please submit this reflection activities. They are part of your final grades. And then also they are to prepare you for the exam. So this giving you some the kind of structure, giving you the kind of structure the exams we follow. We are not going to write codes, but we are expecting you to learn how to interpret. We want you to think like a compiler. Think like a compiler, learn how to act, to interpret, to be able to interpret your code. So, and that will be all for today's class. Thank you very much, and see you on Thursday. See you guys on Thursday.
Thank you.
You're welcome.